In this session, we are going to discuss the later part of the transaction introduction. Hence, it is very important for us to understand uh, why do we need transaction recovery and what do we mean by transaction recovery. We will also discuss the different states of transaction, and we will see what the system log looks like and how it maintains the transactions according to their states. Now let's get started to understand what do we mean by transaction recovery. A transaction might fail because of certain conditions. For example, okay, yeah, this is the first condition. Transaction may fail because a computer fails. For example, you are trying to transfer money from your bank account to another bank account, and when you have transmitted, when you have taken the money out of one account and then you transfer it using your system, using the browser into another account, and then suddenly the computer fails, the system crashes. In this case, the transaction was not complete, and hence there could be a chance that if the transaction is not terminated, then it is there is a high possibility that the money will be deducted from your account, but it did not get deposited in another account. In this case, both of the accounts will show the short of money. Hence, in this place, the transaction has to be stopped. Later on, when the system works properly, the transaction have to be recovered and the transaction have to be re-executed as per the need. Hence, a system failure can cause a transaction to fail. For example, a hardware or a software error that occurs in the computer system during the transaction is executing. In this case, there could be a possibility that hardware crashes and the content of the computer's internal memory gets lost. So in this case, the transaction can fail. So what is the cause? What is the first cause of transaction getting failed? It is called as due to the computer failure or system crash. A transaction may also fail because there was a system error. The first is the system crash. The second is the system error. Now, what happens when the system errors or the transaction errors? Some operations in the transaction may cause it to fail, such as now, for example, you're trying to carry out a transaction, but inside the transaction, there are certain instructions that is causing the transaction to fail. For example, you are trying to carry out a transaction which is having an integer overflow inside it or divide by zero error. In this case, the transaction cannot be completed and hence the transaction will fail. This is also called as a system error. Transaction failure may also occur because of erroneous parameter values or because of logical programming error. In addition, the user may interrupt the transaction during the execution. For example, you are trying to buy something from Amazon, and while there is a processing going on to connect to the bank and read your card and take out money from it, you suddenly decides that you don't want to pay for it as of now, and then you click on the escape button. This is the example wherein the user may interrupt the transaction. The user may interrupt the transaction during it is running. So the transaction, it causes a transaction error or a system error, and the transaction is failed. The third condition is the exceptions or the local error conditions detected by the transaction. For example, data for the transaction may not be found, or a condition such as insufficient account balance in the banking database. For example, you went to Extra and you're trying to pay the bill, but you do not have money in your account. So the card is rejected. In this case, the transaction fails, right? So this is a case. Or a program abort in the transaction also causes it to fail. What do we mean by a program abort? A program, using or the program performing some action fails, then it will fail the transaction as well. Okay, for example, you are trying to print So here printing is the transaction, and suddenly the printer software gives you the error. It exits with some system error or a program abort. The printing will also stop. The fourth condition is concurrency control enforcement. The concurrency control method. Now we will talk about concurrency control method in detail in the second half of this chapter. For now, it is very important for you to understand what does the concurrency mean. We have discussed about the concurrency control in the asset properties and the types of control in the transaction introduction 1 video. So please go there and revise the concept of concurrency. I will give a quick overview here. Concurrency means two transactions are running in the same time on the same data item in an interleave way or in a parallel way. Now, uh, when more than one transaction is trying to access the same data item, there is a high possibility that they may come up with different problems, which we discussed earlier, like the loss update or the dirty read, or many such problems. Hence, it is very important to control the concurrency to make sure that one transaction doesn't intervene or make the changes or leave the system in the inconsistent state. Hence, the concurrency control method may decide to stop one transaction and restart this transaction later because it is trying to create or push the database into inconsistent state, or it is violating serializability. The serializability itself is a very big topic. We will discuss about it in the upcoming slides. They could be this, stopping could be because of several transactions are in the, or it can also happen that the different transactions get into the deadlock state. Now, what is a deadlock state? It is like transaction one is working on data item A. Transaction two is working on data item two. Now, transaction 1 is waiting for transaction 2 to release data item B, and the second transaction is waiting for the transaction 1 to release the data item A. Hence, they both are waiting for each other forever. This is called as a deadlock. In such cases, the concurrency control mechanism will kill one of the transaction and take the data item from it and give it to another transaction so that the other transaction can complete, and after this transaction completes, the concurrency control mechanism will give the chance for the other transaction to run on these data items. The fifth case is when the disk failure occurs. Some disk blocks may lose their data because of the read or write malfunctioning, or because of the read or write head crash. This may happen during a read operation or a write operation of the transaction. Hence, the disk fails, also the transaction fails. Physical problems and catastrophes. This refers to the endless list of problems that includes power connection problems, power shortages, or air conditioning failure, fire, theft, sabotage, overwriting disks or tapes by mistake, and mounting of a wrong tape by operator. So all the physical problems can cause one of the causes that we all discuss. So uh, uh, finally, the system gets into, or the disk or system error happens, and then the transaction fails. So all the physical problems are categorized into this sixth cause. Now let us talk about transaction states. A transaction, as we know, that it is an atomic unit. It means it cannot be divided further. However, a transaction can have many instructions inside it. So it is never possible to execute the half transaction for some time, do some another work, and do the next half of the transaction. It is never possible. It is not possible to divide the transactions into multiple parts because it is just an atomic unit that is either completed or either completed or not done at all. When we say that it is either completed, it means it has to run in its entirety. For recovery purposes, the system needs to keep track of when the transaction starts when it terminates, when it is safe, or when it is aborted or ended. Safe means committing a transaction state into the disk. So, with this concept, the transaction states are divided into 5 states. The first one is the active state, the last one is the terminated state. From the active state, the transaction actually starts working. The terminated state is when the transaction ends or completes. So it's very easy to understand. This is the starting point, this is the ending point of the transaction. The second one is when it is active, it is doing some work. So it saves this half work. So this is called as partially submitted state. After completing the work, it will save the state of the transaction into the disk. This is called as committed state. If there is any problem while executing, then the transaction is set to fail. So this is called as the failed state. So how many states of the transactions are there? 5. What are they? Starting active state. What is the end one? Terminating state. What is the second one? Partially progressing state, also called as partially committed state. And the third one is committed state, and the fourth one is failed state. Now, let us see how the recovery manager keeps tracks of the operations that are written into the transaction state. There is something called as begin underscore transaction. Whenever this operation occurs, the transaction starts working. This marks the beginning of the transaction execution. When the transaction has begun, it will either read or write. After doing this read or write operation, or after executing all the transactions inside the all the actions inside the transaction completes, and this is called as end underscore transaction. This specifies that read and write transaction operations have ended, and they mark the end limit of the transaction. So it's like begin transaction will start the transaction, and then the end of the transaction will complete the transaction. At this point, it may be necessary to check whether the changes that have been introduced by executing the transactions are permanently applied to the database, or whether the transaction has to be aborted because it was violating the concurrency control or for some another reason. So when the transaction starts, it will perform some actions and the transaction completes. If these 3 things are done successfully, then it is very important to make a check and see the changes that are introduced by the transactions are successful and they are written into the database. If there was any problem in reading the reading action inside the transaction, writing action inside the transaction, or begin transaction or end transaction, then or that it is violating the concurrency, then it has to be aborted and nothing is returned, no changes are updated into the database. The other operation of the transactions, which tells that the changes introduced by the transactions are successful and they need to be written into the database, then we say we have to commit the transaction. The instruction that is used to commit a transaction is called as commit underscore transaction. This signals a successful end of transaction so that any changes that are made by the commit underscore transactions are committed safely to the database, or are written safely into the database. Once it is written safely into the database, you cannot undo that. You can delete, however, that's a different option, that's a different discussion, but it is never undone once that transaction is committed. Now we said that if there is any problem in reading and writing of the transaction, or it is violating the concurrency control control situations, then the transaction is aborted. How do we abort the transaction? We abort the transaction by using a transaction rollback or abort. This signals that the transaction has ended unsuccessfully. If the transaction completes successfully, you commit the transaction. If the transaction is completed unsuccessfully, then we have to abort the transaction. Okay, so that any changes or effect that our transaction has introduced must not be applied to the database. Okay, it must be undone. Okay, so very important two operations, commit and transaction, commit underscore transaction and rollback. Rollback is also called as abort. Now let us see what is rollback doing and what is redone. What do we mean by redone? There are two terms called as undo and redo. Undo is similar to rollback. You're coming back, you are unsaving it. Okay, but except that it applies to a single operations. So when you have a single operation to cancel inside the transaction, then you use undo. Redo specifies that the certain transaction must be redo to ensure that all the transactions of a committed transaction have been applied to the database. Okay, now let me give you an example of redo and undo. For example, we are in the transaction. No, forget about all these things. Just look into the half part. Transaction 2 is having a read operation, addition operation, and a write operation. So after you read the item X, okay, and then you perform the addition, and then you think that there is some problem inside this action, only this second action, then you undo this. So undo is applied to one action inside the transaction, okay? And then you perform the write item operation. This is the example of undo. Redo means, for example, you are reading item X, okay, and then you did the subtraction. You want to do the subtraction again because there was some problem, or because you just want to do it again 2 times. So it is redo. Okay, so based on the situation, you either redo or undo the transactions. They are just providing you a way to, like, for example, you write something in the paper and then you feel it is wrong, then you erase it. Erase with the eraser, right? So that is undo. Redo is like you're doing the task once again. Okay, so the transaction states. Okay, so you see here, this is the starting point where the transaction begins. And this is the ending point where the transaction terminates. When the transaction begins, okay, it can abort because there is some problem when it started in reading or writing. Okay, and then we abort. It is failed. After aborting, the transaction is failed and it is terminated. In this case, if the transaction is going through this way, we are saying that the transaction completed unsuccessfully or transaction aborted. It means that it terminated unsuccessfully or the transaction failed. They all means the same. Now, if the transaction is active and then it carried out the actions inside it successfully, and then it, and the transaction, and it is progressing towards the end transaction, the middle part of it called as partially committed. There are chances that even after partially committing the transaction can fail because it is not complete yet. After doing the partial commit, when the transaction moves to the final commit stage, it means the transaction have done all its actions correctly and then it has reached to the commit point and then it is committed. So when you reach to this point, it is said that the transaction has completed successfully. When you reach to the terminated state through this pathway, then it is called as the transaction completed unsuccessfully. So you see how many states are there? Active, terminated, partially committed, committed, or failed. So there are 5 transition states of the transaction. System log, also used for transaction and recovery. System log is like a record wherein you are just telling that which transaction have started working, in which data item is it working, what is the change that it have performed, did it end it successfully or not successfully. you can consider the chance, you can look into one of the example like this. For example, during the examination, the examiner comes to your room, and the other examiner goes into the other exam room. There is an exam log record maintained, which tells that which instructor has gone into which classroom and was there for how much time, was there any problem in the time of exam. All these things are written so that we make the record of what's happening. Similarly, the system log also maintains the details about the transactions when they are working, when they are active. To make and what is the benefit of maintaining the system log? It will help only, it will help greatly when there is any problem with the data item. We lose the value of the data item, there's some problem introduced while doing the transaction. Then looking at the system log, we can recover the transaction and get back to the previous state of the data item. Let's talk about it in detail. The system log, let me show you how the system log looks like. Okay, this is the type of log records that we have in the system log. I will show you. Okay, come back, come back, come back. Okay. Okay, we will see how the system logs look like in another slide. Okay, for now, let us concentrate on the concept of system log. Okay, so here we have the layout of the DBMS log record. Okay, so I'll come to this point. Now let us see the system log and the components inside it. Actually, the system log is a critical component. It is something, very important for DBMS. It provides operational and security benefits. It ensures the integrity of the database is maintained with the help of recovery in case there is a failure. It will also help in auditing and monitoring the DBMS and support various DBMS managements and optimization tasks. This system log or the critical component have very important parts. And what are they? Log or general, the way how it recovers from the lost or excuse me, from the lost or some whenever there is a problem in the DBMS, okay, and the DBMS crashes, we need to recover. So it has a protocol for recovery. It has some way of recovery. It uses strict protocols. It may use log records. Okay, it may also use commit point of a transaction to perform the recovery, monitoring, and supporting the optimization task. So, what are the five important parts of the system log? The five important parts of system logs include log or general protocol for recovery, strict protocol, recovery using log records, and commit point of a transaction. Now, let us talk about the log, also called as a journal. The log keeps track of all the transactions inside it that affects the value of any database item. Now, if you see, we have it here. Uh, we have it here. Oh, 1 second. Yeah. What does it has inside it? It have a record identification, transaction working on this, operation code. It can be insert, delete, or update, or begin transaction or abort transaction. Record the before image and record the after image of the DBMS. Okay, so the log keeps track of what transactions are running and affecting the values inside the DBMS. This information is very important, which will help us to recover from a transaction which is failed. For example, transaction T1 was working on data item X and data item Y. It changed the values of X and Y, but the transaction failed. So the X and Y should go to the value before executing the transaction. The log, okay, this is the first thing. The second thing is the log is kept on the disk. So it is not affected by any kind of a failure except the disk or the physical or catastrophic failure. Where do we save this log? We save it inside the disk. In addition, the log is periodically backed up. So you take a backup copy of the hmm, log periodically, like every month or every week. And it is archived into the storage tape to handle the catastrophic failures as well. Okay, so this is the first part of it. Transaction uh, log record types. There are 5 transaction log record types. The first one is starting the transaction, and the last one is aborting the transaction. So it is given as start underscore transaction, and the T, it means the transaction T started executing. Then we have a write item or transaction T, item X, the old value and the new value. Now, if the transaction is performing a write task on item X, then its old value is recorded and its new value is also recorded. Then we have read underscore item, transaction T on item X. It means that transaction T is reading the item X. Commit, comma, transaction. It means the transaction is recording, okay, the changes that have been performed into the database by the transaction. Okay, so it is like committing the transaction. Abort transaction T, it records the transaction T have been unsuccessfully completed, and hence it is aborted. The T is actually the unique transaction ID. So instead of T, you will see transaction, T100, something like that. So this is the ID of the transaction. So how many types of log records we have? 5 types of log records we have. Now, talking about the protocol for recovery. The protocol for recovery is nothing but the way how we recover from a unsuccessfully terminated transaction. A very common approach is by cascading the rollbacks. Now, let us look into this figure. We have transaction T1, then T2, T3, T4, and T5. Transaction T1 read an item A and it write something, perform a write operation on A. Then T2 started, it also read A and then perform a write operation on A. T3 also did the same thing, which was made by, which T3 read the value which was written by transaction T2. Transaction T2 read the value which was written by transaction T1. Now all of them are performing read and write, read and write, read and write operation one after the other. And the transaction T, similarly, the transaction 5 is reading the value written by 4, transaction 4. Now we have like a failure. See, after T1 did the work, T2 did some work on T1, then T3 continued working on the work done by T2. Then T4 worked on T3, T5 worked on T4. Now T1 failed. It means this also have to roll back, T3 also have to roll back, T3, T4 also have to roll back, T5 also have to roll back. So it is like a cascading rollbacks that happen one after the other, one after the other. All of them have rollback. Protocols for recovery that avoid cascading rollbacks do not require that read operation be written to the system log, whereas other protocols require these entries for recovery. So a cascading rollback says that if the transaction is reading, then we do not write the details about P1 that it read, because reading is not making any change. Now let us see what is the strict protocol do. The strict protocols require simpler write entries that do not include new values. So if we are not making any changes into the values of A, okay, the simpler entries will not include, unless the simpler write entries that do not include the new value. Okay, this is called as a strict protocol. The protocols require simpler write entries also. Okay, that do not include the new value inside it. Okay, so we will talk about the strict protocols in detail in section 21.4. Okay, so just now remember that there is a protocol for recovery that avoids the cascading rollbacks. which will avoid this situation. Okay. And the strict protocol requires the simpler write entries. Okay. Simple write entries that do not include the new value. It is just writing about the new entries and not including the new value inside it. Okay. Now, recovery using the log records can be done in two ways: undoing and redoing. Undoing is like tracing backwards, redoing is like tracing forward. If the system crash and we want to recover from it, then we look into the system log. And then by either undoing and getting back to the old values, or we keep on doing the things and we reach to the new point. So we either use undo or we use redo. It is something like your system was working fine, okay, from 1 month. And then suddenly today you install a new software inside it and the system crashed. So every system has a recovery point. Okay, so here the recovery manager will run the system recovery, and then you keep on undoing. You will undo the software that you have installed. You will undo all the changes that have been performed by installing this software. And you keep on doing it until you reach to the place where the system was working properly by undoing all the values, older values. Redoing is like you started performing some, operation. Okay. You did it correctly for the first time, the second, the third, and fourth. And then in the fifth time, there was some problem. So what you do is you keep on, repeating the fifth one and so on until your system works properly. Because the log contains a record of every write operation that changes the value of some data item, it is possible to undo the effects of these write operation of a transaction by tracing backward through the log and resetting all the items changed by a write operation on T to their earlier values. We can also recover by redoing the transactions by tracing forward through the log records and setting all the items changed by write operation of the T that did not get done permanently to the new values. So this is redoing, okay, and this is undoing. Undoing, you undo the older values, you redo the new values, and then you reach to the point where the system was working properly. Commit point. What is a commit point? A commit point of a transaction is reached when the transaction executes successfully. It means it has performed all the actions inside the transactions and have been recorded into the log. This is called as a commit point. Okay, so beyond the commit point, the transaction is said to be committed and its effects are assumed to be written in their database permanently. And we do this by we represent the commit of the transaction by using commit comma T into the log, system log. Rollback of transactions are needed for transactions that have started but did not reach to the commit point. It means there was some problem and it was unsuccessful, so it did not reach to the commit point and hence it reached to the abort. So in this case, we have to roll back, redoing the transaction and force writing a log. Transactions that have written their commit entry, okay, must also have recorded all their write operations in the log. Otherwise, they would not be committed. So their effect on the database can be redone for the log entries. It is something like your transaction is doing some write operations, and these write operations have not been saved, but there was no problem also. So this will be lost then because you did not save it. So you have to redo. For example, you're typing on a word processor, you write something, first paragraph and second paragraph, and then you did not save it and you wrote it correctly. So what you have to do, you have to save by redoing it or by rewriting it, and right. So this is called as redoing from the log entries. You look into the log entry, you see the transaction 1 executed properly, transaction 2 executed properly. So you redo the first and the second one. At the time of system crash, only the log entries that have been written back to the disk are considered for recovery process. So how if the system crashes, only those transactions which entries are available in the log are redone. Okay, because the main memory has already, content inside the main memory have been lost. Force writing a log. Before a transaction reaching its, see, when the transaction reads its commit point, the changes are made into the log and saved into the disk. This is normal. But when you want the transaction to save before it completes, then it is called as force writing a log. Before a transaction reaches its commit point and any portion of the log that has not been written to the disk yet, you are making it safe now. You are making you yet you're saying that it must now be written to the disk. This process is called as force writing the log before committing transaction. Okay, so we know that the transaction starts, works properly, made the changes into the database and the log, and it is saved into the disk. This is called as commit for the transaction. But when you do commit for the transaction is happening, if you notice, only after executing the uh, completion or reaching to the completion of the transaction successfully. But when you want to save before even completing the transaction successfully, then it is called as force logging or force writing a log. So that is it. We will talk about schedules in DBMS in the next video.